I spent a lot of time looking at I2C YouTube videos with the multiplexer, the TCA9548A. I needed to send data between two STM32F4. I use both the F401 and the F411. These are called Black Pills. And I needed to communicate between the two black pills and also display data for each of the STM32s. And that was on different 0.96 inch displays. I needed the multiplexer as both displays have manufacturer addresses that are the same, and the I2C Bus uses the address to identify a device. There are a lot of videos on the YouTube that show exactly what I needed to do, both wiring and code. But I was thinking about what happens if you needed to attach more than 8 devices, since the TCA9548A Multiplexer gives you the capability of extending your I2C bus by adding 8 addresses, and they can be the same address, every one of them. I put this prototype together with more than one multiplexer, which would handle multiple addresses of the same kind. So on the first one, you could handle another 7, and on the second one you can handle another 7, and on the third one you can handle 8. The reason it's 7 on the first 2 is because you've got to go from that multiplexer to the next multiplexer, which takes one of the 2-wire pairs. This prototype is executing as you see it. You can't really tell too much, but the line 3 is changing every 5 seconds. As it goes around the 5 displays. It may be obvious to you, but it certainly was not obvious to me how to get the multiplexers to go from one to the other. I spent a lot of time trying to make this prototype work, even though I'm not sure why or how I would ever use it. It does turn out that the I2C is a short distance communications protocol, but and the multiplexers could extend that, so you could possibly make your I2C bus go a longer distance. The rest of this video, I plan to tell you what this prototype is doing, how it is wired, and I'll show you the code that I'm using both in both STM32s. In doing this, I'm going to hold the camera, so there may be a little jitter in it, so I can get a little closer to the various components. Okay, now I need to turn the power on, I want to show you that the display is coming up as I do. So this is going to be the power for the one of the STM32s. Okay, and then what I want to do is put the other one together. Okay, and you'll see the displays come in 1 second apart, and you can see that the line 3 will update every 5 seconds, as there's a delay of 1 second between each display, and all 5 of them are being updated from the one of the STM32s. Okay, now I have this as a responder requester. You can think of this as a parent-child relationship. Whereas the requester is sending a message to the responder saying, send me 12 characters of data. and then the responder gets it and sends it to the requester. And that 12 characters of data is the hello world that I display on the 5 displays. Okay, also on the 5 displays, you'll notice that the very first multiplexer has address 70. I'll tell you more about that when I get to the wiring. And it's using there's 8 pairs going from 0 to 7, and this particular display is on the 7th pair of the multiplexer that has address 70. And of course over here you have address 71, and the left one is on the pair 2, and the right one is on pair 6, and the third one is address 72, and the left display is on the second pair, and the right one is on the 6th pair. They don't have to be on the 2nd and 6th in these 2 different ones. They can be any of them. It's just that I had it set up that way on one of these breadboards, so I set it up that way on the other breadboard. But I'll talk to you more about when I get to the wiring. Okay, let me just tell you why I even have 2 black pills going, and I need communication between them. In my YouTube channel, LotBot Robotics, I discuss a project that I'm working on for robots and for drones, and that one is called the LotBot Base Project, and there's an update to it that went from the blue pill to the black pill. And the issue is that I'm using 2 receivers, and one of the receivers is primarily I'm going to be allocating it to the movement functions of the drone or robot, and the other one is going to be sort of maintenance functions as well as some other settings. So I'm going to have one of these black pills take care of the movement function, and the other one is going to take care of the setting type functions. Also, if you notice, there's a little XT60 plug with a little switch on it, and I find it difficult to put XT plugs together as I'm doing a demo. So I've developed a little switch, and there's a video on my YouTube channel that shows how to put that together if you can't see it. Okay, if I go to the very first multiplexer, you'll see the address is 70, and if you look at there's 3 little wires, orange wires, they're going to ground. You don't, if you're just using 70 and don't need any other multiplexers, you don't even have to ground those. It'll default to 70. But that's how the addresses are established. There's a pins A0, A1, and A2. And if I go to 71 over here, you'll see that A0 is connected to voltage. So it's sort of, the 3 bits are sort of an octal arrangement where not hexadecimal because it's only using 3, and the 7 is evidently defaulted. So it's sort of like a octal byte as opposed to a hexadecimal byte. And A0 being high voltage would be a 1, and if you had A2 high voltage like over here, and the other 2 is ground, that would be a 2, and then if you had all 3 of them going to voltage, that would be a 7. So you can go from 70 to 77. Okay, getting back to the first multiplexer, you'll notice that, let's see, this wire right here, these 2, they're going over to the other STM32, and that's how the parent is asking the child, if you will, parent-child relationship, to get the data. Okay, and then that's on, let's see, that's on pair 2. And then if you come over to this display, you'll see that it's on pair 7. And notice you do need these resistors rather. I've seen on the different YouTube videos that they use anywhere from 4.7K to 10K. And I've since the first video I saw was 4.7, I simply start using 4.7K. And this display is set up for 7. And then you'll see that there's 2 wires coming from this multiplexer. Let's see, those are these 2 right here. And these 2 are going to go over to the second multiplexer as the input. And it's coming off of, let's see, that's pair 1. Okay, then we go over, and you'll see this in the code, by the way. These other wires, by the way, that are flat, it's just these 2 are just making the voltage and ground stream here the same as over in this other side. So I could pick up ground and voltage on both sides. And if you're interested in the way that I communicate serially from the Mac that I'm using, this is just a USB serial port, and it just goes into the RX and TX over in these 2 pins here. Let's see, those are A9, A10. So the RX here would be the TX on here, and then the TX over here would, the TX here would be the RX here, and the TX here would be the RX here. Okay, that way you can communicate from the Mac to download the programs, and of course you have. But anyway, that's explained also if you're interested in one of my other videos on my YouTube channel. Coming back over here, on this particular multiplexer, I'm using 2 for this display, and I'm using 6 for this display. And I pick up, where do I? Oh, I pick up from 1, this 1 pair here. That's how I get to the 3rd multiplexer. And then these 2 displays are using the same pairs that these were over here. The key thing you really want to make sure you do is put these pull-up resistors in for every single one of these lines. Okay. One other thing. Let's see. When I actually use this in the project I'm working on, I'm going to be using this one. This is made by Adafruit. It's a little smaller and will fit on my board a little better. So these are these ones that I'm using here a little wider. Okay, now let's look at the code. I've put the video of the prototype on the display, so you could use it as a reference to the code that we're going to be talking about. On the left side, that window is the child. If you're thinking of a parent-child relationship, it's the STM32 that's going to be responding to the request for information. It's a very small, simple program. You have to have the include of the wire.h, and then in the setup, you do a begin of the this particular child, this STM32. So this is beginning this one. And it's processing a on request. So when it gets a request from the parent, it'll execute the response function. And the response function simply writes out the hello world that you see on the displays. The loop does nothing. I have a delay in here only to have an instruction in it. So this is the complete code for the STM32 that is giving the response, and I called it the child. Going over to the other code for the parent, if you will, or the one that's doing the requesting, you have the include for the wire.h, and then for the displays you'll need the Adafruit GFX library and the SSD1306.h library. And then for the 5 displays, I simply just took the default. So I didn't really worry about any of the parameters that you can specify to decide how big of text you use for the screen as a default. The string response equals is where I'm building the hello world as it's received character by character. The response character is the individual characters coming back that go to build the response. The I count, it's a single counter that I increment every time I do a display on one of the displays, since there's 5 and I have a second delay between them. So this count simply increments, and you'll see it in the displays as 1 apart every time it increments. On the next display, it's 1 higher than the previous display. Okay, this is a routine that allows me to look at the different multiplexers as well as the different pairs on the multiplexers. Okay, so I get the 70 or 71 or 72 in here, and then I get which pair that I want to use from 0 to 7. This right will actually position me in the correct multiplexer at the right pair. Okay, in the setup, I do a wire.begin. I could put an address in here, but usually in the parent you don't really need one. And I do a serial begin if I want to write anything out, and I don't in this particular code, just like I didn't in the child, but I have it there in case I want to do any serial debugging. The first display on the first multiplexer 7, this display is at the pair 7. Okay, and then the second display, it's on the second multiplexer at pair 2 on 71, but in order to get there, you have to go to the 70 multiplexer, the pair 1, which goes to 71, and then you're on the pair 2. So you can then establish the second display on the pair 2 on multiplexer 71. Okay, same thing holds true here. You go to pair 1 on multiplexer 70, and that goes to 71, which then you use the pair 6 to define the third display. Now, on the third multiplexer, 72, you have to go to the first multiplexer, to the first pair 1 to get to 71, and then you have to go to the first pair on 71 to get to 72, and then the display is on the second pair on the third multiplexer. And the same thing holds true here, except that the fifth display is on the sixth pair on the third multiplexer. The clear and display is just a way of getting the display initialized to nothing. Okay, in the loop. Now, in the loop, I'm going to go to the first multiplexer, the second pair, and that's when how I get connected to the child over here to get the response. I've defined it as the address of 12. That's because we set up 12 here. The only reason it's 12 is because I'm bringing down 12 characters and I just made it match. This could be almost anything that is not one of the addresses that's on the manufactured devices. I put a small delay in here because I have to be able to go over to the child, get the data, and have it start coming back. So I wanted a little bit of delay. I think that's enough. It seems to be in my prototype. Then while there's data available coming in, I do a read for that data and I simply concatenate it to the response that I'm building, which will be the hello world in response when I need it to put out into displays. Okay, the first display is at pair 70 on multiplexer 70. I do a clear display, I set the text, I make it white even though the display only has yellow or blue. This is just the base color that will be used for whatever the display has. I set the cursor to 0, 0, and I print out the response. Now the response doesn't really print at this point, it waits for this display. So this is sort of building a buffer, okay? And then I do the print of the response, which puts it out at 0, 0, and the character size is small enough that if I start the next row at pixel 10, I could put out the display 77. So I'm showing that I'm on the multiplexer with address 70, and I'm going to be using the 7th pair. And then I put this count out at the beginning of the line defined by pixel 20 going vertically. Now, and as I print out the I count, I'm incrementing it. So the next time it'll be 1 greater than this on the next display. I put a delay of 1,000 in there because if I left it go without a second display between the displays, it'll zoom through and you wouldn't have been able to see if there was any counting going on between the displays. Okay, then the second display, again, I'm using for multiplexer 70, the first one. I'm going to the pair 1 to get to 71 to get to the pair 2 in order to put out this data on the second display. Again, the count increments after it prints out the count. And so on. Same with this one. Now, on the 2 displays for the third multiplexer, again, I have to say that I'm going to the first multiplexer address 70, going to the pair 1 to get to 71, and using its pair 1 to get to multiplexer on 72, and then this display being on 2. And okay, now the same holds here, except I'm looking at port or pair 6 on 72. Now, I did not learn about using these concatenated pairs to get to the third multiplexer. It just happened as I was developing things, I discovered it. Now, if there's some other way to do this and somebody knows it, I would appreciate hearing from them in the comments. Otherwise, this is what I did, and this works, as you saw in the demo. And that is the code. Well, this is the project that I put together, and I hope you enjoyed it. If anybody actually finds a use for it or does anything with it, can you please let me know in the comments? I'd certainly like to know that. Well, thanks for watching it.